So I'm happy to be here. I've actually really enjoyed these 2 days and learning a lot about what's going on in R&D and digitalization and manufacturing, and it's been interesting for me. When SciEx asked me to present on the smart manufacturing, I was really not sure where to start because it all depends on your perspective. So at Covestro, or a company like Covestro, it can mean anything. And so today I'd like to go over a few things about who is Covestro, because we have to have the formal slides in there, and a little bit about what we're doing for digital at Covestro, and then through the value chain and what that actually means to us as a company and to the industry. So Covestro is a leading world of plastics. If you don't know the name Covestro, most of you in here probably do, though. We used to be part of the Bayer Group, Bayer Material Science, and spun off Covestro in 2015. And we've had a very good few years, and I'm happy to be part of the Covestro portion of that. So we have over 14 billion euro in turnover and nearly 17,000 employees listed on the stock exchange, and a global player. We have a large portfolio all about making better materials. But personally, what interests me is the innovative portion of Covestro. We have over 1,100 employees strictly looking at research and development, and we also have an innovation department where we are building up data scientists and digital labs and all that at Covestro so we can make progress faster. So tradition by innovation. You can see here that starting with Bayer Otto in 1937, the inventor of polyurethanes, all the way through today, our company is driven by innovation. And all of this is all part of R&D, so it's very interesting for me personally to see what other companies are doing, but also what we do at Covestro. So our focus at Covestro is on sustainability. And you might think, this is what all the corporations are saying now, but I actually, earlier this week, I was with Covestro's process development community, and we were talking about sustainability and projects that we're doing that are focused on the circular economy. So there's been a decision made that 80% of our R&D projects will go towards improving the sustainability goals. And we've also decided recently that 80% of that money is going to be on those that actually drive major change for sustainability. So it's an exciting time, I think, in the industry, and then for me personally, because I'm secretly a nerd, and I think 2019 is now a good time to be a nerd. So when we look at digital at Covestro, we're actually doing everything. And with 17,000 employees and all these people focused on innovation and digitalization, we're doing it across the whole value chain. So we do have digital business models. We are looking at customer experience and how do we improve that. And there's numerous examples that we could go into. But a couple of highlights. We're actually selling chemicals on Alibaba, which I never thought would be something that would happen. And so it's an interesting platform to see, does it make a difference if you're bidding for the chemicals as to if you can sell more or buy more or how that's worked. So it's been a learning experience for us as a company to see how we can leverage digitalization across the market and actually improve our sales. For digital operations is where I'm going to focus today, and so because we're doing a little bit of everything across the whole value chain and trying to tie all that together. So when we look into this just a little bit deeper on digital operations, this is everything that goes into the development of products and the making of products. And so it's fun for me because I get to talk to people all over the company and all over the world in how they're bringing their knowledge into the field and what are we doing to make improvements on that. So I have a few examples of how we're implementing AI, how we're doing it in R&D, quantum chemistry, and just a couple of highlights. So when we look at digital R&D, actually this is personally, I learned about digital R&D in more detail a couple months ago. So this summer I attended the economics program at Oxford, And one of my colleagues there was there with me, Dr. Thorsten Heinemann. And, you know, I've decided that the best ideas and the best collaboration happens after a couple of glasses of wine, after dinner, with a napkin, and we're drawing and talking. So we decided on some next steps on how we would bring technology and R&D together in order to have better products and better circular data. So when we look at digital R&D, and Thorsten can go into a lot of detail on this, but we are actually using a high-performance computer and quantum chemistry in order to evaluate new materials faster. So these computers are taking years off of our R&D time in the lab. So historically, we would tweak a recipe, make a small amount, run it through test again and again and again and again. So with the quantum chemistry and the high-performance computer tied together with some deep learning algorithms, we're actually able to learn faster and predict better whether or not a certain material type is going to be successful. And then, of course, we still take it to the lab and prove it or disprove it, and then it would go on to a mini plant and then scale up. But it's really made a big difference in how we're improving polyurethanes and taking them to market. So here's just some deep dive into the data here. And if I was actually a chemist, I'm not, I'm a mathematician, I could go into these details. Thorsten explained it all to me, and it was very fascinating, but I can't give a repeat on that without messing it up. But they're doing work on all this area. And they're actually currently evaluating whether or not adding quantum computing to the mix will even speed up faster how that looks. So just some of the things that digital R&D does, and I didn't realize this. So Thorsten, to get out of the office every so often, he actually goes to the customer sites. And he talks to them about their products. And what are they making out of it, and how are they performing? And how can we take those learnings from our customer and bring them back into R&D and improve our processes, and so at the end the customer actually has a better product. And so some of these items here are showing about how different ways that we've done that. We've helped our customer improve their products. So when we look at digital engineering, so this is something that we're also doing, where we're turning all of our 2D drawing information into 3D information, but metadata. And I agree completely, taking all the brownfield information, it's hard to determine is it really worth the effort. Greenfield, absolutely, following the CIFOS methodology or the standard template where we have the metadata all in one form. But we are going to take, we call it a pilot, but take one of our plants, so MDI Caojing, and see if we can't do a smart copy on our investment project in Baytown for the next MDI plant. And, you know, we will have to change a little bit because the layout of the plant is a little bit different. Some things will be changed on that, but we expect that if successful, which of course we will be, we expect to save on engineering costs. And then over the lifetime, as you have more and more metadata tied together, you actually have more efficiency on engineering, and you have better quality in your information. So if you have it all tied to SAP, for example, and you're changing out a pump, maybe you're putting in a different size motor or changing the propeller size, you update your SAP asset information, it automatically writes it back into the plant portal here for the engineering database and updates the metadata for the drawings. So the next guy goes, and if he wants to spit out a mass diagram, or a flow diagram or something, then it's got the most recent asset information. It's all linked together. So I've worked in automation for 30 years, and the first thing we always did was take our drawing and walk out to the field and check it. And I'm starting to feel hopeful that after 30 years, maybe it'll be correct. So this is our goal. So when we go into digital manufacturing and the innovation of making products, we actually have done significant work in the APC realm. Advanced process control, operator training systems, end-to-end supply chain automation. We're doing a lot of that, and it's very good. But we want to do more with the data. And when we look at the whole picture, it's really complex. So we have all these different trials going on, all these different things that we're doing, all these different companies we're working with and trying things out. And it's really difficult to actually pull it all together and make it work. And as most of you probably know who are at the medium and larger companies, it's analysis paralysis. We can run a pilot for years and never actually do anything with it. So I've been in this position for 2 years now, and I've been trying to figure out who's doing what where. And we have these pockets of excellence all over. And then how do we pull all of that together and actually bring the innovation across the board and gain from that? Wrong way. So, sorry, I was going the right way. It's coming apart. When we look at this, and there's obviously an updated number on here because this is next year already, but Business Insider tells us by next year we'll have 34 billion connected devices. And that's quite true, but how much are we actually using? In the chemical industry, it's probably less than 1%. So we want to utilize that data, turn it into actionable insights, and actually make progress. So we have several projects going on. So one of them is called ProDavos, and it's really about utilizing current information that we have, current architecture, and what can we do better with what we already have. But it's really a process expert focus. It's not necessarily for operations, but the process experts. So in our technology centers, we have one for each business unit, and they do exchange, but then they have dynamic models that they're doing to plan new projects with or to help troubleshoot. But there's always problems like, well, a transmitter failed, so my model broke. And the operator doesn't care about that particular sensor, so now I have to wait until somebody reports it and gets it fixed, and it might be months. So we're doing things to help some at-a-glance visualization, which I'll show you. We're looking at some machine learning and some AI algorithms and trying to make better use of the data in a more effective way and actually know when the sensors fail, which is one of the pilot projects we have going on. So when we look at the architecture, and this is all mostly existing information. So everything's self-service analytics and down. Absolutely, we have progress in those fields, and we're doing all sorts of interesting things with it and trying to make use of it. But we're looking for a way to standardize and roll out and engage people. And if we look a little bit more just about the at-a-glance visualization and tools that we're doing, so this is a quite simple heat exchanger here, but it's actually one of my favorite examples because it's so easy to see. And we're just using PyVision and asset framework templates and things like that and writing in some calculations. But you'll see here they did the heat transfer coefficient. And as an engineer, you can look at it and say, well, it's starting to foul. How much longer do I have? But what's interesting is we also have a link into our asset maintenance history. So we've actually have our own standard tag name nomenclature where they're all tied together by assets now with the AF templates. And we can pick, based on the AKZ, out of SAP, what does it look like? So the asset engineer could look at that and say, well, I've been fouling and I haven't cleaned that exchanger for 6 months or something like that. But what's nice is with PyVision is you can make it once and you use it infinite times. So with Asset Framework, you're actually grouping everything together by assets, all these sensors together. In Covestro, 30,000 assets and 500,000 sensors, it's a lot of garbage, a lot of data. But if you can group it all together into all the same type of heat exchanger, which has the same sort of like this KF01 in the middle of the tag name, it could go find, this tool that we're experimenting with, can go find all the other assets like that and assign these groups to it. So it's really fascinating. But what's nice is that you can easily just pick another asset and it's going to come and look exactly the same. Okay, so everyone around the world will have the same at-a-glance visualization for all of our assets. An additional thing that we have here is we've actually linked it with a self-service analytics. In this example, it shows Seek. We've tested a couple of them. But really quickly, with a couple of clicks, you can get an interpolation of the line and have an idea of how much longer you have under certain conditions that heat exchanger is going to last. Now, early in my career, back in the 90s, I did all this by hand, right? I download all the data into a spreadsheet and try to figure out how much time do we have, and it's really hard to predict failure rate because things change. But you could look at this and say, well, my next outage isn't 6 months, but it's saying I've got 4 months based on history, and maybe cut back to about 80% so you don't take it down early. And then after a few days or week, a couple weeks, you get some more information. It will show a change in the shift in the line. So these are some of the ideas that we have moving forward, where we're going to be having prescriptive maintenance and operations based on actual process data. So this was actually mentioned the other day, yesterday, I think. And I have not touched these slides since, I think, Monday, so I didn't get it from there. But we look at digitalization as augmented intelligence. We will not take the humans out of the equation. We need the subject matter experts. We need the operator in the field who's that sanity check, right? Does all this make sense? And then at some point when we're actually doing prescriptive operations and prescriptive maintenance, and say we give the operator 3 choices, hey, I see this is what I think, and the operator takes a choice, it could feed back into the data model, and the model could learn from it. So that's kind of the general idea that we have. Clearly, we're a long way from that, but it is possible. So another example that I want to give you is on using machine learning. And for anyone who's used Prism, it's really just a basic machine learning tool. It's really meant for assets. And you take the information, you train a model with good data, and then it'll tell you when it starts to deviate from normal, right? It's just pattern recognition. And so we had a large 7.5 megawatt motor that's running a compressor, one of our feedstocks, that failed. And all the operator got was a ground fault alarm. Well, what's he going to do with that? Nothing. So what ended up happening, this motor failed. That's, for anyone who knows how big that is, it's not something you keep in your warehouse that you go and pick up on break and install in the field. And we had to find another one of these motors we can install it. And we were actually down for a couple of weeks because of it. And then the motor that we did find that was fairly close had to be retrofitted just so it could fit. And but had we had information ahead of time that was intelligent, we could have ordered the motor in advance. We could have maybe scheduled an outage to do some work on it, what have you. So for GRINS, we took all the data and we wanted to go back and see, well, does this tool really work, right? So what we did is we had a training period. It's about a year's worth of data, and about where we trained it for what's normal conditions. And this little green line here just shows there's a deviation. So there was a short outage there and what have you. But as you go along, you start to see these little warnings and alarms. And if the operator was on the board and he got an alarm that he didn't understand, if he also had a data model he could look at, which might see a change in normal, then he would be more likely to agree to trust the alarm, or to maybe say there's something behind it. So we have done these sort of investigations on, 20, 30 failures to decide how are we going to actually approach this problem. But the biggest worry we have really is false positives and missing issues. And as we did experiments, so we even tried doing this back calculation on a heat exchanger leak that corroded one of our product lines. And we could tell when it started to leak, but we couldn't tell before it leaked, right? So there's some good and bad. But on the model for the heat exchanger, we actually had the alarm at like maybe 0.25% and then 0.5%. So it was really small. And after the fact, you can always find the error, right? I mean, that's the nature of the game. On this one, it was like a 1% for the warning, 2% out of the box, no tweaking on the model, and it was very easily seen. So what we've decided to do to try to speed up success is to take all of the known failures, run that data through a model, build the model off of that data, and then take that same equipment around the world and actually apply the same model. You'd have to retrain it for the right data, but you would have the right warnings and alarm settings. So my opinion is that it's actually going to be closer. So we don't have to worry so much out of the box, is it right? Because we've got some history to go on. And then everything else we'll have to learn. So it'll be an interesting journey for us. So a question that keeps coming back to me is, why does PCT every few years redesign what we're doing? And I never really saw it that way because we've always made incremental progress. And the same for operations as for maintenance. Our OEE is actually quite high, and our on-stream time and operations under control is quite high. But we wanted to roll out these digital tools, and what's going to make everyone keep it, going to want it, you know? And we really have to involve the people. If you do a top-down push, the guys in the field, your blue-collar workers are not going to be so interested because, you know, they weren't engaged, they weren't part of it. And so what we're doing now, we're doing a pilot rollout of various tools in one of our plants in MDI Caojing in China. And the whole purpose is to define those roles and responsibilities, workflow processes, how do we appropriately engage local operations and local maintenance so that they own it. And by the time we walk away in 6 to 8 months, we want the whole unit to be applied, but also the job descriptions of the people to have changed and that they have adopted that this is their new way of work. And then as we do that and we learn from that, then we can put together a timeline, overall cost, and what does it take, and actually roll out to the rest of the units worldwide. And when you think of the analysis paralysis, I suggest that if you find something you like, just start doing it. And then once you get to rollout is when you're asking for the big money. And it's going to be more accepted if you're actually doing it. It's going back in loops for years, trying to prove something, you've missed the window. So tying it all together is kind of what I've been focusing on actually for the last year, is how do we make all this work? So we have all of these different tools in different ways around the world, and we're doing different things with the data, but it's, again, pockets of excellence. It's not cohesive. So we're looking currently at how do we connect all this together, and this could be anything, data lake or cloud or something, but this is basically going to be an asset hub in the middle here, where it's going to be the engine driving all this information back and forth, for example. So we have our metadata here for our engineering. We'll have PHA studies, so if you're changing your SIL rating, you want your drawings to be updated and the information updated in your assets, and all that needs to be hooked together. So these are some of the things we're working on, is actually connecting it all. But in addition to that, we want to, this is with Torsten Heinemann and I discussing how do we do this, is we're going to put together a full digital signal along the value chain. So basically like a capsule of data. So when he goes to the customer and he understands, okay, this lot had this result, we need to be able to easily connect it to the process data of the unit that it was sold from. So what I learned last week is that the process information, the real-time process information, is separate from our process experts and is even further separated from our R&D. So the process experts can see the data, but they don't control any of that information. We've got 30 sites and then maybe 100 production units around the world that they're kind of watching. But the R&D guys don't understand or don't know what was actually produced in that unit, how it was produced. Was your reactor temperature a little bit higher than normal? Was whatever, and how does that all link? So our idea is we're actually going to have like a cockpit is what it's called, and I think on the business side we've got a project called Avatar, which is in the idea stage. But from a technical standpoint, looking at the data and the digital signature, is we want to tie together the quantum chemistry and at some point be able to tie that to our dynamic simulators, actually build the plant with that information, turning it into metadata, track and trace to the customer, quality control of the customer, and actually feed all that information back so you've got the whole value of the chain. But not just from orders and deliveries, but really at a molecular level as to what we're doing with that process and how can we improve the efficiency and sustainability of doing that. So that's kind of where we're headed now. So now technology and R&D are working together, which is fun for me because I find R&D very exciting. But we actually are doing work in all these fields. So we have a significant amount of progress in every field as to what we're doing and trying to capture and bring it all together so all sites and all units have the same thing. So I just have some takeaways, what I considered highlights, and it's mostly focused on manufacturing. But if anyone has any questions, I'd be happy to answer.
Great, thanks, Jane.